Today, in this tutorial, I will show you about Introduction to Nano Measurement
Director of the
Tools.
Research Triangle Nanotechnology Network, or RTNN. In this video, you will be introduced to some of the common tools we use in nanomeasurement. Nanomeasurement tools are tools or instruments that help us visualize and/or characterize something at the nanoscale. Nanomeasurement tools are not fundamentally different from traditional measurement tools. In any measurement experiment, we are trying to define or discover properties of something. The property you want to measure will affect what measurement tool you use. Consider this. If you want to measure your height, this property can be measured with a tool like a regular ruler or meter stick. If you wanted to measure something smaller, like the length of your hand, you would still be able to use the same ruler or the same tool. However, at some point, the ruler tool is no longer useful. If you wanted to measure, say, the thickness of a strand of your hair, you wouldn't be able to accurately quantify the property you want to measure. The tool is neither designed to measure nor characterize at that scale. The subdivisions only go down to millimeters, about 10 times the thickness of your hair. 1 million nanometers are in a single millimeter, or the smallest subdivision on our ruler. This is the scale we are measuring at with nanomeasurement tools. Visualizing and characterizing a specimen at the nanoscale presents significant challenges and requires highly specialized tools and equipment and highly knowledgeable operators to use them. For starters, we need tools to help us visualize down to the nanoscale. At best, our naked eye can really only visualize features about the thickness of a single strand of hair. We use microscopes to help us visualize objects and features we cannot see with our naked eyes. In a traditional optical light microscope, a light source illuminates the specimen with visible light and magnifies and focuses the image with a system of lenses. Using optical light microscopes, we can visualize objects as small as blood cells and bacteria. Not all microscopes use a beam of light. Electron microscopes use a focused electron beam instead of optical light. The beam of electrons is accelerated, focused, and scanned along the sample. Electrons bounce off the sample and are detected to generate a magnified image of the sample that we can see with our own eyes. Electron microscopes are even more powerful than optical microscopes and capable of allowing us to see things as small as individual atoms. While being able to see at this scale is an astounding feat in itself, we must also use tools to help us measure properties at the nanoscale. There's a vast amount of tools and different techniques used within nanomeasurement, each with a unique means of helping us understand a material. A lot of the tools we use involve bombarding particles onto the sample, such as light particles called photons, ions, or electrons. Light and electron microscopes work in this way. A beam of electrons or light particles allow us to generate a magnified image of a sample. Each type of particle, ions, electrons, and photons, will interact with the specimen in a unique way to reveal different information about the material. The sample might alter the path of the particles, like how a prism refracts light into different colors. The way the incident light particles change direction after hitting the material can be measured and can reveal information about the material. Or the particle can cause changes in the material itself, like structural changes or absorbing energy and vibrating bonds within the structure. Forcing these interactions to occur and measuring them helps us define and discover properties at the nanoscale. Properties that we can determine using nanomeasurement tools include how big, or in our case how small, something is, what it is made of, information about the molecular structure, and the strength of micro-sized or nano-sized features. Some tools have the capability to observe and measure how these nanoscale properties change when the material is exposed to external factors like physical stresses, changes in temperature, or radiation. For instance, in this video, We see a live SEM feed of a piece of glass frit on a special stage that can heat up to very high temperatures within the microscope. Once the glass heats up to its melting point, we can see how the particle changes as a result of the temperature change. In the realm of nano measurement, there are so many tools available to help us uncover information about the world around us. I hope you have enjoyed this video, and thank you for watching.